the Energy Management Coordinator for the Nash Rocky Mountain Public Schools and has over 37 years in the energy, DDC controls, and maintenance fields. He is responsible for developing the energy program and saving costs, reducing energy, implementing new programs, scheduling the DDC, plus verifying and correcting operation of HVAC and DDC systems. Mr. Lamm has successfully completed the Energy Management Diploma course with North Carolina State. Prior to his position at Nash Rocky Mountain Public Schools, Mr. Lamm was a maintenance director of a public school system, serviced and installed HVAC or electrical systems, and is licensed in the HVAC and electrical areas, installed or programmed DDC. He also served in the U.S. Navy. So, Charles, you want to go ahead and take it over from here?
Thank you, Eric. I appreciate the opportunity to speak with everyone today. And I'm known in certain circles as the building whisperer. And I tell people I talk to the buildings. And a lot of times we actually get some answers back. I'm hearing a little static, so I hope I'm getting through. Now, the top secret guidelines got two rules. Rule number one, improve the comfort levels and the energy savings will come. And rule number two, see rule number one. You don't need to go any further. It's improve those comfort levels. Don't be greedy and look for every nickel and dime. Concentrate on your comfort levels. Some barriers that you're going to run into, I've got my all-time 4 up there from we need to run the building all night to it's always been that way. If I hear these things, then I automatically think cha-ching, money in the bank to be had. Now, are you a detective? Do you ask the simple or the right question? The wrong question is one that you don't ask. And a lot of times, where would I start at? The biggest user or the highest KBTU per square foot? Well, it depends. Your biggest user may be the building that's used the most after hours by the community. And you might would have to trim that in order to lower the usage of the building. If you're using Portfolio Manager, I would suggest that you look at the 50 to 75% Energy Star rating. 75% is eligible for Energy Star, and 50 to 75% would be no-cost, low-cost methods to bring those buildings up. Go right back to improving the comfort level. Now, who can you help? When we look at that, I say energy consultants, anybody, engineers, and yes, our teachers can help even though they don't realize it sometimes. And basically the plan for my school system has evolved over the years that we started back in '94 with performance contracting. In North Carolina, we're allowed to contract with the vendor for energy savings, and we use those energy savings to buy new equipment, boilers, chillers, whatever. And we did 2 phases of that. In '03, we did rate structures. We have 2 power companies. One offers time of use, and we asked them, were we on the correct rate? And we were not with all those accounts, and that netted us about $40,000 in 1 year just by simply getting on the right rate structure. We hired an energy consultant in '06, and there helped us get our program up and running quickly and avoid a lot of the mistakes that happen. And also probably we recommissioned our DDC system around '06, and there we simply look at our system, is everything in the logic correct? And shortly after that, we moved on with Energy Star and got them to come in and help us. And as you can see, we're now it's a people program. Nobody's a Lone Ranger here. What does it mean when you say too hot or too cold? That doesn't mean anything to me. Everybody's opinion is different. What has to happen is upper management guidelines for comfort levels. You need to measure and verify the room space temps. You need to look at the humidity and the temperature, and some equipment controls off dew points. Now, when you need to benchmark. When you're benchmarking, you need to know where you're at and how successful you've been. There's several tracking systems out there. I don't know all of them, but I know Utility Manager Pro and Energy Master Pro and Portfolio Manager. And these are systems designed to track and can upload to Energy Star. And you want to track your energy, your water, your usage, and you want to see your cost savings, and you want to be able to apply for the Energy Star. Energy Star buildings use about 35% less energy, and this is a picture of one of ours, which is Red Oak Middle, built about 1997, and is water source heat pumps. Data loggers are a great tool to help troubleshoot. Now, this is a snapshot of one of our schools that was a real energy hog, and it had a lot of IAQ problems, which we've solved. And with data loggers, you're looking at three things: relative humidity, that's in the blue, space temperature in the black, and dew points in the red. Okay, now if we simply narrow that and look, all right, look at the temperature and the relative humidity. All right, if our temperature, you notice that during this time we played around a little bit with them just to see the effect of humidity. I can tell you that dew points need to be 15 to 20 degrees lower than the space temperature. In this case, they're not. And I can also tell you, according to EPA, that the relative humidity that's above 60% for a period of more than 48 hours, you're likely to have mold or mildew. And we refer to that as a moisture problem because that's exactly what it is, and mold seems to panic people. Now, this particular school is a hot water, chill water school, and if you notice that 60% of our alarm levels, and if you look at the blue, for the entire test period, we were in alarm. So there's a lot of issues here, and I can also tell you that with dehumidification, this boiler is running 24/7 and not dehumidifying. First thing people ask you, well, what's the range for relative humidity? EPA will tell you 30 to 60%. Okay, and then the question might be from that, well, what's the optimum range inside that window? And EPA will also tell you that it's 50 to 55%, and at that level, it helps to control dust mites. Now, after we went into the building, we checked everything. And I'll show you some of the things that we did in a minute. But look at the space temperature, basically the same in the black, but look at the humidity levels. Here's my alarm level at 60%. Now you can only see a few spikes that would have triggered the boiler for very short periods of time rather than the entire time. And notice where our humidity's camped out. We're in that 50 to 55% of the range most of the time. So this was a successful campaign in this building. Took about 2 months to achieve. Now, some of the things you got to know, it is definitely a people.
Charles?
Yes.
But before we get too far away from the data loggers, we had a question on just sort of how and where the data loggers were installed.
Okay.
To
That's a great
generate
question.
the data that you're looking at there.
Yes. Okay. Typically, data loggers need to be installed near the thermostat or the return vent. If you place them near a discharge or supply vent, then if you're heating, you're going to get excessive hot air, or if you're cooling, you're going to get excessive cold air. So locate the thermostat, and typically that's probably by the door, and you're going to find the return grill probably by the door. Somewhere there that it can sense the room would be a great opportunity for you. And another thing to point out here, we did a great job on the comfort level. We'll look at the next problem down here. What do you see? If you know anything about a building, you know that you have night setbacks, unoccupied times and unoccupied temperatures. Well, our unoccupied temperatures in the summer are 85 degrees. Notice that during the weekend, right here, we're hitting about 75 degrees. Well, we did a great job improving the comfort level, but if I whoops, well, let me go back. If I go a little bit further on problem number 2, I need to get this up to the 80 to 85 degrees, and things would do a lot better for us and save a lot more energy. Okay. When when you're a detective, you need to ask the question, do you have the piece of puzzle to fit your program? Is it fully implemented? Things like, is the equipment working correctly? Are the time clocks working correctly? And BAS, sequence of operation. BAS stands for Building Automated System. Some know it by DDC. Some know it by the Energy Management System. But if you look at my puzzle, the thing that I have to figure out, where do I go once I have all these in place and I maintain and verify all this? What is next? Well, that's something your system has to decide. For us, it's load profiling, which I'll show you in just a minute. Some of the areas we're going to look into briefly will be air handlers, the central plant, heat pumps, and the energy management software logic. BAS, lead lag is nothing in the world. It says 2 pieces of equipment. One leads this week and runs, and if needed, the second one turns on. Next week, we simply switch that so that both pieces get equal run time. RH is relative humidity. Important to know now what the parameter is that we maintain that. CWS, HWS, cool chill water supply, hot water supply. Very important to know what your building design is and what the building can do given certain parameters. OAT is outside ambient temperature, and outdoor temperature resets are a great way to save energy in mild weather. OSS blocks, optimum start-stop. This can back a building heating system up on extremely cold days so that your comfort level is maintained at the correct time. Cooling set point, heating set point, and SPC is the space temperature. You need to know these things when talking to a mechanic. Now, on the mechanical side, things like an AHU, an air handling unit, what does it do, or a primary-secondary loop? Primary-secondary loop with a mixed valve simply says that what you have is a boiler with a pump running through a loop system, and we draw off of that to supply a zone. Now, the boiler is sitting there running, say the design temperature is 180 degrees. But the mixing valve only lets 140 degrees to the building because the day is unusually warm and we don't need that much. Well, when that happens, the boiler doesn't run as much and you save energy. SEER, Seasonal Energy Efficient Ratio. What that says is the higher the number, the more energy efficient the piece of equipment is, the more money you'll save. PMs, Preventative Maintenance. Can't tell you how important that is. Central plant is the equipment in the mechanical room, the boilers, the chillers, the pumps. Now, it's easier to be proactive than reactive. And the first question with air handler units is, how often do the PMs, are they performed? And here we're looking at the belts, the motors, the pulleys, cleaning the coils, stroking the valves. And one of the things that missed the most is the hot water, chill water strainer. A lot of times I talk to the guys and I say, they tell me, well, we did all this stuff. Did anybody check the strainer? Most of the time they didn't. And about 90% of the time we can find a problem there. And the central plant, it's important for all your equipment to be cleaned, inspected, and is running correctly. If you have a school that has water source heat pumps and you have a dirty heat exchanger, I can guarantee you're having a lot of problems and using a lot of excessive energy to maintain that building, if you can maintain it. Now with heat pumps, nothing different there. You need to occasionally check the refrigerants as well as the filters and cleaning coils. Did you know that a dirty filter or a dirty coil that is stopped up can reduce the efficiency by a piece of equipment as much as 20 to 30%? Now, you have a building that has a design degree which says that at X amount of temperature we can deliver a comfort level, and that's at 100%. Well, if I've lost 20%, I only have 80% because today I'm above design conditions and I can't do it. I can't heat or cool it. So it's important that you clean the coils and change the filters. If your BAS system, building automated system, has been installed for more than 2 or 3 years and you've never recommissioned it, lots of money to be had to be saved here. Okay, if this system was, in our cases, we had systems installed in 94. We were not thinking energy strategies at that time. You may be able to spend a little money, change your strategy, and be able to update and save money simply by the software logic. Does your HVAC equipment cut off at night? Have you ever thought about that a building needs to rest like you do? Can you work 24/7? Well, yes, but probably not well for very long. Well, the building's the same way. You can do it, but you're going to run the building in the ground and reduce the life of the equipment. Night setbacks save energy. Allowing a building space to drift higher in the summer will allow what I call passive dehumidification, and it's a no-cost deal. To dehumidify a space, you need to add heat. Well, you can add heat by simply holding the system back and letting the building temperature rise, and then if it hits 85 degrees on a Saturday afternoon, let it come on for a little while, and probably use the strategy of, like, say, 5 degrees. Let it cool for X amount of time, and then let it go right back unoccupied. And leaving equipment on or leaving lighting on reduces the life of that device significantly. Now, some of the problems we encountered that might happen to you, Johnson Controls and N30, check your date, clock, and your UTC offset, Unitary Time Controller. Example, what happened to us is I asked the man one day, we were not lining up with our temperatures with our times, and he said everything was correct. So I asked him to show me, and date, clock, perfect. UTC, I saw a number of 360. And I said, what does that mean? And he explained it to me. I said, prove it. So we went to the manual, and we went right through the manual, and sure enough, it said 360. But when we flipped the page, it said for Milwaukee, Wisconsin. So we're sitting in eastern North Carolina. So we had the wrong UTC. As soon as we changed, ours is 300, everything went perfect. No problem? Yes.
We've got just a question that came in. It says, what do you recommend HVAC, BAS programming for buildings that are intermittently and partially occupied after hours?
Okay, well, I recommend that you only run the space that's needed. There's no reason, even if you have, here's a good example. We had a high school, we had one classroom for 4 halls, one schedule. So, and we were constantly having to use one wing. So what we did, we broke them down into 4 wings. And now, in the classroom, let's say we've got 50 classrooms, just pick a number. And we only have 15 on this hall, and we have the rest split between the other 3. Well, why don't we just run just the 15 when I only need 2 or 3 classrooms? Makes more sense than running the whole building. We have nobody in the gym, so, you know, we have multiple schedules and break it down that way and only use what is required when we need it. I hope that answers that question. And if you have a Barbara Coleman Network 8000, you might want to check your time and check your OSS block, optimum start stop. What is the maximum time that you will allow the system to back up in cold weather? We found that typically you had an hour or 2 hours. Somebody had changed hours, and we had as much as 10 hours on some schools, and you'd have schools starting up for a 5 o'clock startup, 8 o'clock the previous night. So need to watch that. Here's a good one. Problem number 3, the zone temps are too cold during the day in the winter, but okay when the mechanic gets there. And the question is it the teacher? Well, maybe, maybe not. In this case, it wasn't. What happened was on a Network 8000, you need to check your default times and default set point values. And basically what that says, if you lose communication, that we will maintain this set point or this heating or cooling and the heating will be slightly lower and the cooling slightly higher. And if the mechanics know this, they know to go check the value to see if that device is talking to the main panel. Logic water source heat pumps. Do you have these, and are they operating starting before the system is at its design loop temperature? If so, you probably got a lot of problems with tripping devices. And do you have more than one schedule, which goes back to the other question? And I might add to that during the morning when we start up, we stagger our startup times to avoid the KW, a peak KW during startup times. And basically what I do, I break my building down into thirds, and I bring the third on that people will be in the building first or the hardest to heat or cool. And if the optimum stop, do you know what the time is for yours? Or you can go ask a question. Outdoor temperature resets to boiling loop controls. Can't say your part of the country can tell you about us here in eastern North Carolina. Something that you need to dial in your building. We use typically 30 to 60 degrees OAT, or outside ambient temperature. At 30 degrees, we'll deliver 180 degrees to the building. That's the design condition. At 60 degrees, we will reset the loop, not the boiler, to 140 degrees. The boiler's still doing 180, but if I only draw 140 off, the boiler does not run as much and effectively shuts down, and the building does not overheat as much. And that's kind of just a starting point. You might have to change it differently if you're in Maine, let's say. Or if you're in Florida, you might can get a little more creative. The thing to watch here is don't try to do this with the boiler. Unless you have what is called a condensing boiler, and you set that loop supply below 140, the boiler will condense, and that will cause damage to the boiler and shorten its life. Reporting. Need to make reports to the upper management and show people how well you're doing or how well you're not doing, and the help that is needed. And this is one of our reports that we use, and it shows in the green diamonds, this is our, from here, this is our base year, this is where we were at, and you can kind of see that this represents about 30% reduction here. So we did fairly well on that one. The one thing I wanted to really concentrate with you today is two parts of an electric bill. And basically, you have the kWh with the amount of energy used over a period of time, and you also have the kW that you're billed for, which is the speed of the energy consumed. And the easy way to look at that is, how long did it take you to drive from your house to the beach? All right, that's kind of like how they charge it. And then when you took this vacation, did you go 50 mile an hour or did you go 70 mile an hour? Well, if you go 70 mile an hour, you're going to pay more. So the question becomes, when it comes to a building, do I want to walk to work or do I want to run to work? As far as savings, you really need to run to work. Now, this is some information that I pulled out, and we're working with Automated Energy, with our load profiler, and there's a lot of things with that package, but we have concentrated on demand. So we want to know everything that we can do to reduce our demand. In 2008, you can see that this had a max demand for that month of 664 kW and a load factor of about 32% during the week. What's important here is the 664. That's what we're paying at $10.10 a kW. So that was with the energy program with no load shedding. Now, in 2009, a year later, we are down to $5.99. That's a 65 kW reduction. Now, from this, we're up on our load factor, which we should be, and we found some logic issues with a hot water heater, and we did what we call passive load shedding or load management, which simply means we talked about scheduling the building in thirds. We know that a K-12 school building has a maximum window from 10:30 to 2 p.m. That's when your maximum load should occur. Anything before that is money you can save. And we had a lot of spikes around 7, 8 o'clock in the morning, 15, 20-minute spikes. So we scheduled by 1/3, and we were able to reduce the KW by 65 KW. That's significant when you start talking about $10.50 a KW. Now, this year, we installed load shedding equipment. Now, you see our load factor is up to 47%. That's great during the week. Now, you see our KW is down to 523. What we did, we started, and you notice that instead of just Mondays, it's different days of the week. You can see Wednesday, Tuesday, Friday, and so forth. But 523, well, we went down to 141 KW. That's over $1,000 a month savings by installing this. Well, typical cost of this project may be $4 or $5 grand. And if I save $1,000 in a month, it doesn't take long to pay for it. I can also tell you that you need to dial your building in, and we were very conservative with this. What we did was, this had we knew we had 640 kW, so we said, okay, load shed at 550. And then we saw that we were not using it that much, so we lowered it to 500. I can tell you, as of today, this building now sits on a 460 kW, and we're hitting around 490, 500 kW because we don't have anything else we can shed with it. So we actually had this down to around 500 now, which we thought was outstanding. And we can carry that for 10 months out of the year. Our biggest challenge will be January and February because this is a heat pump with electric strips. But we're expecting to load shed 150, 200 kW if we manage it correctly. And one of the things that needs to be understood is, remember rule number 1, improve the comfort level. Well, they do not need to know you're doing this. This is not cutting the equipment off. This is load shedding. If you do it correctly, nobody ever knows that you're doing it, and you have saved a ton of money in the process. Okay, with automated energy, I want you to see, this is a middle school that's hot water, chilled water. Notice that during early March, we're still in the heating mode. Look at our KW. We're really camped out around 250. We're doing pretty good. Just as soon as we go to AC, we almost double our KW. That's a lot of money. Okay, so what this tells us is we have a bunch of air handlers here, and we don't really have the opportunity to shed like we do at another school with heat pumps and compressors. So what we have is a change in the chiller logic to determine what this KW will be. In other words, make it real simple. Got 2 chillers, and I want both running at the same time. That's what we're currently studying, and then we may change the logic and see if we run both on staggered intervals, will it unload and reduce the KW. Right now, it looks to be run one, bring the second one on if needed. And also, there's a second clue here to what's going on. You see it right here. You see this Monday with things going down on Friday. This is another school, Bienvenue. This is water source heat pumps here. Look at this pattern right here. You see that same pattern. Well, what that tells you is if you're going to do a passive load management, you do not do Monday through Friday, which you'll waste energy, time, and money. All you really need to concentrate on, all you need to concentrate on is right here, Monday and Tuesday. Okay, I'll give you a good example of this. And here again, we're talking about dialing in the building. Wednesday through Friday, we start up. The first zone comes on at 5 a.m. Maybe what I do is on Monday, I start up at 3:30. Or maybe I start up on Tuesday at 4:30, and I don't start up quite as much, but I give a little bit back. In other words, to reduce this and bring this down equal to these, and see if we can manage that just a little better. Now, what does that mean for us in terms of savings? Cost avoidance savings of over $5.7 million, and my boss refers to that as the check that you don't write. Now, hard dollars, which is actual money in the bank, we have a total of $485,000 in 5 years. Now, part of that, which I think is significant, billing errors, simply monitoring your bills by somebody that understands the bill and can tell if something's not right. We found $191,000 in billing errors that was refunded to us. Now, you need to understand as well that it's, the power company's not the bad guy here. We're a customer with, we have 29 schools. We have some 175 accounts with somewhere over 300 meters, and we're just one customer. How many meters will a power company read during a month? So the odds are that something might get entered incorrectly or a meter might fail, and it's up to the customer to monitor bills and to work with the power company. I think that's extremely important, and this shows almost $200,000 in savings just by monitoring it. And don't dump it on the secretary that pays the bill, because she does a great job at paying the bills, but she does not understand how to read that bill. Now, if we're looking at environmental impact, I think it's very significant. In 5 years, our greatest energy reduction has been 30%, which helped us get Energy Star Partner of the Year in 2009. We were really excited about that. Over 5 years, we reduced 33 million kilowatt hours. And you can look at the different numbers, but I think an important one to me is the fact that we have the equivalent of planting over 5,000 acres of pine forest, which is, really speaks well on the environmental side of it. Now, from the Energy Star side of it, our program started in 2004. In 2006, we labeled 13. By the end of 2009, we've had 78 awards at 27 different sites. Every 12 months, you can reapply for an Energy Star for a building, and which shows that you're maintaining that building. So we're really excited about that.
Charles, we had a question come in that said, what emission tools and or software do you use to calculate the equivalent savings when you're talking about your pine trees?
Oh, that's a great question. That's a really super question. If you dial up, if you go to Energy Star and go to their website and type in emissions calculator, avoided emissions calculator, they will take you to a software that all you do is punch the numbers in. We punch in like 33,464,000, and it gives us those numbers automatically. We don't have to figure anything. It's there with the software for you, and it's free. It's a great opportunity for you. Now, some of the, today I hope maybe you've learned just to be a detective and to simply ask the question. If you have an energy program, is it fully implemented? And do you have all the pieces working together? And who do you ask about your HVAC, and how is it maintained, and how do you track that? And unfortunately, is your building automated system out of sight, out of mind? A lot of people can tell you they got one. A lot of people don't know how to maintain it. They don't know how to check things. They really need to become efficient at this. And my question would be, who monitors your utility bills, the energy usage, the reporting, and the troubleshooting? We find that storms that come through cause a lot of grief for us. And we have equipment working perfectly today. Tomorrow, the energy system has a lot of problems with it. So one of the things, I have some great websites here for you. You can get a lot of information from them. And if you want to ask me a question, here's my email, and just put on there Energy Star question or energy question, and because it'll go to my junk mail, and then I'll kind of spot it and pick up on it. And hopefully maybe you learned something today. And if you got some more questions, I'll be glad to answer those. And what I'm going to do now is basically try to send this back to you, Cody.
Okay.
Yeah,
I'm going to turn off the, well, I'm trying to figure out how to, we're trying to open it up so everybody can talk at this point. If you, tell you what, if you have a question, hit your question button, and I'll see if that's a way to turn people on here. I see Steve. Well, let's see. All right. And I'm trying to, you guys will have to forgive me for making sure we understand how to work this. I thought we would be able to turn everybody back on so we could hear everyone talk. Apparently, I don't have that option at this point, or I'm not sure how to do that. Are there any questions at this point? Okay. All right, let's see. Okay, Steve, you had your hand up, or the button was clicked earlier. I think I figured out how to turn that off. So if you want to chat, or if you have a question. All right. Okay, we've got a question from Joni. Will you send the attendees this presentation? And we're gonna get it recorded and make it available on our website. And depending on how big the file is, Joni, we'll do our best to get that out. If your email is like mine over a certain size, it may not send out, but we will make it available where you can click and listen to this, and then we'll make sure it's hopefully downloadable, so you can put that on there. This is from, let's see, the next question we have up is, well, shoot. Sorry about that. Do you have a place, do you have in place a behavioral modification program in your schools? Charles, are you? Oh, sorry. I apparently have muted Charles. I don't know how I did that. Charles, are you there? Well, folks, I apologize. I have managed to mute our speaker. Well, look, I have clearly messed this one up here and can't seem to get Charles back on the phone. Charles, are you there? Charles, can you hear me out there?
Yes, I can hear
Okay.
you.
All right. Now I got it back. Sorry about that, folks.
Okay.
So we had a question, which was, do you have in place a behavioral modification program in your schools where your student, staff, and admin and maintenance all come together?
Yes, we do. We started a program back in 2004 with EduCon out of Winston-Salem, North Carolina, and they were instrumental in helping us, teaching us what we needed to know about that. We have a very strong behavioral. We feel that that's just one more piece of the puzzle.
We also got some feedback that it says, great presentation, Charles. We'd like to know more about engaging teachers in the effort to reduce energy. What have you done working with your teachers?
Well, we attack that from several different angles. A lot of times I'll have one-on-one with teachers. If there's a problem, I'll go out and talk to the teachers, or I'll get feedback from the HVAC mechanics on what's going on. And from time to time, we have staff time at the end of the day with the teachers where we talk about the energy program, and we talk about the guidelines, and we talk about their school specifically. If they're not doing well, what we can do to help each other.
Okay. Are there any other questions? Anything out there? All right. If not, then we certainly appreciate everybody taking the time to be with us. If you have any follow-up emails, you've got Charles's email. We'll have this recorded and up on the website here momentarily. and we'll be happy to follow back up with you. I'd like to personally thank Kim Weaver at Rocky Mount, City of Rocky Mount Utilities for helping us get this program set up in her utility and getting Charles on board and allowing us to benefit from Charles' expertise. Every time we listen to folks in the real world who are using technology to manage energy, we learn something, and I very much appreciate it. So thank you all for being with us today, and let us know if you have any follow-up questions. We appreciate it. Bye-bye.